So today we're going to learn how to write and balance chemical equations. So we're going to talk about how do we do that. On this slide, can you see the difference between the bolded words and the non-bolded words? Okay, you only need to write the bolded words down. Okay, so when we write chemical equations, we use formulas instead of words. Okay, formulas are much shorter, it's much quicker. Okay, and so the first step is just to write something called a skeleton equation. What do you think of when you hear the word skeleton? Just like bones, right? Like just the bare bones minimum. So the skeleton equation is just when you write the formulas for the reactants and the products. It is not balanced at this point. Okay, so it's just an unbalanced equation. You just have formulas in the correct spot. Next, when we write our chemical equations, if you know the physical state, we include the physical state. Okay, so the way we include the physical state is we just use a symbol. It goes in parentheses, and it's a subscript that goes after the element or compound. Okay. So S just tells you it's a solid, L is a liquid, G is a gas, and then I want all of you to write down AQ. Okay. So AQ stands for aqueous. Everybody say aqueous. Good. Okay, aqueous is probably the one up there that we're the least familiar with. Aqueous just means it's this solution where it dissolved in water. Okay, so a good example of this is salt water. What happens if you put sodium chloride in water? It dissolves, right? So if you put sodium chloride in water, that makes this aqueous solution. And then down here at the bottom, this is an example showing how we would include states of matter. Okay, so this is iron, so it's solid iron plus oxygen gas gives us iron 3 oxide, and that S tells us it's a solid. Okay. So if you know the physical state, you add the physical state. If you don't know it, like let's say we're doing a worksheet and it doesn't give you the physical state, it's okay not to include it. But let's say we're doing like a lab and you definitely know the physical state. Should you be including those states of matter? If a catalyst is used, we do have to communicate that. Do you all remember what a catalyst is from biology days?
Yeah, it's like protein. Just kidding.
Yeah, like an enzyme, yes.
Yeah, it's an enzyme.
Enzymes are catalysts. What's the purpose of a catalyst? Good. Speed up reactions. Sometimes reactions are super slow, right? We got to speed it up. We can't just sit around all day and watch it. So if a catalyst is used in that reaction, you have to write the catalyst above the arrow. Okay, so here's an example. So hydrogen peroxide, if you add manganese 4 oxide, it breaks down into water and oxygen gas. Okay, this manganese 4 oxide is the catalyst. Okay, so it goes right above the arrow. It doesn't go on the reactant or product side because it isn't a reactant or a product. Okay, it's just there to speed up that reaction. Last Monday, we did that lab where we mixed the zinc and the hydrochloric acid. We had to use heat. Okay, so a lot of times heat's a popular one, so you have to heat to speed that up. So here's heat. Sometimes you just use this little triangle or delta symbol, so it shows that you have to heat up that reaction. Okay. So you don't have to write these all down. Okay, maybe you just pick one of these to write and just know catalysts go above the arrow. Okay, so now that we kind of know the foundations for writing our equations, now we're going to talk about balancing them. Okay. So I have some steps. We don't have to write every word for the steps. I'll just underline what's important. Okay, so the first thing, you have to write the correct formulas for the reactants and the products. Okay, so make sure you have to have correct formulas. It is the same like formula rules that we learned last semester when we did our naming unit. Okay. Also, after our test last week, do you remember you did that naming review? Okay, so same types of formulas. If you have the incorrect formula, are you going to possibly be able to balance that equation correctly? No. Okay, so step 1, you have to make sure you have correct formulas for reactants and products. Okay. Step 2, reactants always go on the left side of the arrow. Products always go on the right. Okay, no matter what. So reactants always to the left, products always to the right. And then we're just going to go through, we're going to count the number of atoms on each side of the reaction. Okay, so we have to make sure however many atoms there are in the reactant side, there has to be equal amounts on the product side. One tip I have, when you get to polyatomics, we count these as one single unit. Okay. And so if you're sitting there like, what does that mean? We'll do 4 examples after this, okay? And I'll like show you what I mean. When we come across the polyatomic ion in the example, I'll point this out to you, okay? Okay, so then finally, when we balance, we'll just go through and balance our elements. And you have to use coefficients, okay? So the only thing you can use to balance is a coefficient. You may never change the subscript. So if you're sitting here wondering like, well, what's the difference between a coefficient and a subscript? Write this with me. So I'm going to write just like 2H2O. The large number in front is the coefficient. Okay. And then the small 2 is the subscript. So if you get confused on what the difference between a coefficient and a subscript is, go ahead and write this down. Okay. So when we balance, you only change coefficients to balance the equation. Okay. You cannot change subscripts to balance. And then once we think we're balanced, you're going to double check. Okay, just double check, make sure if you have 5 hydrogens on the reactant side, make sure you have 5 hydrogens on the product side. And then finally, the coefficients have to be in like the lowest possible ratio. And of course they have to be whole numbers. Can you have a fraction of an atom? Right. Okay. So it has to be like the lowest whole number ratio. So that means if you can reduce your coefficients, then you have to reduce them. Okay, for our first practice problem, I gave you one in words, and we'll write the formulas. I'll go slow through this one just so we can refresh how do we write formulas again. Okay. So we have silver nitrate plus copper yields copper 2 nitrate plus silver. Okay. So step 1 is to just come up with those formulas. Okay. So I'm just going to chunk it. Silver nitrate comes first. We have to first figure out if it's ionic or covalent. So what do you look for to figure out if this is ionic or covalent? What 2 things make up an ionic compound?
A metal and a non-metal.
Okay, metal and a nonmetal. What do we know about silver? Okay, it's a metal. So is it ionic? Yes. Ionic, so then we care about charges. Okay. If you look at your polyatomic naming chart, the one on the back of your periodic table, what is the only charge possible for silver? Okay, just a +1. And then use that naming chart, look up the formula for nitrate. Do you see nitrate? Okay. NO3 minus 1. So we have the charges. What do you do once you have the charges? Okay, crisscross. Do you have to write the ones? No. Okay, so silver nitrate just becomes AgNO3. All right, and then what's copper? Okay. What's the symbol for yields? Okay, just the arrow. All right, so then now we have copper 2 nitrate. So I'm going to write the formula above before I put it in the equation. What does the 2 mean in the copper 2? Okay, so copper has a +2 charge. And then we just looked up nitrate. So we know it's NO3 minus 1. Okay, so we have the charges. Now what do we do? Crisscross. So what does the formula become? So you should be getting like Cu, NO3 in parentheses 2. Okay, and then finally, what's the symbol for silver? Okay, Ag. Okay, so this is step 1. You just have to get those formulas correct. Okay. Then we're going to balance. Okay, balancing is mainly a bunch of guess and check. Okay, that's really what it is. So if you have a pencil, pencil is ideal at this point. Okay, if you don't, write light. Okay, write light. There are a couple ways to balance. Some people just like literally pencil in numbers, then erase it and try new numbers. I like to teach a list way. So underneath the reactant side, I'm going to list the elements. Okay, so my first element is silver. Okay. And then there's also silver on the product side. So I'm going to just list them. Okay. Next is nitrate. Nitrate's one of those polyatomic ions. So we took a note on this earlier. Do you see how it's NO3 on the reactant side? And do you see how it's NO3 on the product side? Okay, because it's nitrate on both sides, keep it together. So that means we're not going to break it up into nitrogen and oxygen. We're going to leave it as NO3. Okay. It is much easier to keep it as NO3 than to break it up into nitrogen separately and then oxygen separately. And then finally, the last element is copper. Okay, so everyone try the list for this first example. So now we're just going to count how many of each atom there are. So in silver nitrate, how many silvers are here? Okay. 1 silver. If we look over here, how many silvers are there?
1.
Okay. All right, next is nitrate. How many nitrates are here? Just 1. Nitrate is NO3, so just 1 total. Okay, how many are on this side? 2. You have this little 2 here. So I'm going to write a 2. How many coppers?
1.
And how many coppers? 1. Okay, so if you list out what you start with, then you can easily see what's already balanced and what isn't balanced. Okay, so we can see silver and copper are balanced, however nitrate isn't. So there's 2 nitrates here. So the only way you can balance is you just do coefficients. Okay, coefficients have to go between the, like in front of the entire compound. So I'm going to put a 2 in front of silver nitrate. Okay, so now there's 2 nitrates. However, did another element also get affected? Okay, what other element was affected when I put a 2 here? Silver. Okay, so now there's 2 silvers on the reactant side. So what do you have to add over here? 2. Okay, so now if we look at our list below, do they look balanced? Okay, always go through it one more time and make sure there's no mistakes. So I just start on the left side. So I see there's 2 silvers. There's 2 silvers. Okay. This 2 distributes to nitrate. Okay, so there's 2 nitrates, and then there's 2 nitrates. There's 1 copper, 1 copper. So are we balanced? Good. Okay, next one, aluminum plus oxygen gives us aluminum oxide. So go ahead and copy this equation down. All right, once we copy the equation down, then we'll just tally up the elements on each side. How many aluminums are on the left? 1. How many aluminums are on the right? 2. How many oxygens are on the left? How many oxygens are on the right? 3. Okay, so for this one, I'd recommend we start with the oxygens. We have 2 and 3. Okay, so one's even, one's odd. When you have this situation, try to find like a common multiple of them. So what's a common multiple of 2 and 3? Okay, so we're going to try to make it 6 on both sides. I would start on the complicated side. Okay, so what coefficient do you have to add here to get it to 6? Okay, so I'm going to put a 2 there. So now we have 6 oxygens. What other element did that affect? Aluminum. So how many aluminums? Okay, so on this side, what do you have to add to get it to 6? Okay, so I'm going to add a 3. And then what do you have to add in front of aluminum? A 4. Good. Okay, so our tally looks balanced. Again, just go through it one time. Make sure everything is balanced. So we have 4 aluminums. What's 2 times 2? 4. So 4 aluminums. What's 3 times 2? 6. What's 2 times 3? 6. Are we balanced?
Yes.
Good. Okay, go ahead, copy down this one. Okay, once you copy this equation down, I want you to count your starting elements. So fill out that list, and I want to check. But like, let's see, can you count your starting number of elements without my help? Okay, how many silicons are on the left side?
1.
Just 1. How about the right side?
1.
1. Okay, how many chlorines are on the left?
1.
How many chlorines are on the right? Just 1. How many hydrogens are on the left?
2.
2. How many hydrogens are on the right?
5.
Okay, 5. There's 4 here, and how many are right here? 1. So 5 total. How many oxygens are on the left?
1.
How many oxygens are on the right?
4.
4. Okay, so when we look at our list, we can see silicon is currently balanced. Then it doesn't matter which element you start with. We could just go down the list. Okay, so if there's 4 chlorines on the left side, what do you have to add over here to get it to 4?
4.
Okay, so I'm going to put a 4 there. So we have 4 chlorines. Thank you. Okay, did that affect any other element?
CL.
Okay, what else? Besides Cl, which other one did it affect? Hydrogen. So how many hydrogens are here?
4.
4. And how many are here?
4. So 8.
So 8 total now. Okay, so if I just keep going down the list, the right side now has 8 hydrogens. So what do you have to add over here to get this one to 8? 4. Okay, so now hydrogen's balanced. And then what other element did that one affect? Oxygen. How many oxygens are there now?
8.
Just on this side. This 4 just distributes.
4.
So there's 4. Okay, so do we look balanced? Okay, we're just going to double check one more time though. So there's 1 silicon, 1 silicon. Okay. 4 chlorines. This 4 distributes, so 4 chlorines. Okay. What's 4 times 2?
8.
8 hydrogens. There's 4 here plus 4 here, so 8 hydrogens. Okay. This 4 distributes, so 4 oxygens, 4 oxygens. Okay, last one. This is the hardest one, so everyone do this last one with me. So go ahead and copy down this equation. Okay, how many carbons on the left side?
7.
How many on the right?
2 or 1.
1. How many hydrogens on the left?
6.
How many on the right?
2.
2. Okay, how many oxygens on the left? Okay, 4. There's 2 plus 2, so 4 total. How many oxygens on the right?
3.
3. Okay, 2 plus 1 gives you 3. Okay, take a look at this reaction up here. So these are what I call some of the harder balancing ones. These are called combustion reactions. So you're going to start noticing patterns. Okay, so the pattern you're going to notice in this one, you start with, I just want to be red right now. You start with some sort of hydrocarbon. So some sort of compound with carbon and hydrogen in it. Then when it's plus O2, you're burning it. And then products will always be carbon dioxide and water. So you'll kind of start to recognize this pattern. The reason why this one becomes difficult is you can get really large coefficients. Okay, so I have like a little trick that's going to help us so it doesn't take forever. So if you have a pencil, write in a pencil right now. If you don't, write light because we will end up erasing. Okay. All right, so when we have these hydrocarbons, I'd recommend just starting with the carbon. So there's 7 on this side. So what coefficient do you need over here?
7.
Okay, so I'm going to put a 7 there. Okay, so I have 7 carbons. I'm going to save oxygen for the end. Okay, so I'm going to ignore oxygen for a moment. Yeah, but I'm going to save that one. Okay, then we're going to look at hydrogen. There's 6 over here. So what do you need to put over here to balance out hydrogens? 3. Okay, so now we're going to recount the oxygens. What's 7 times 2?
14.
Okay, so there's 14. And how many oxygens are over here? 3, right? So this 3 distributes. So what's 14 plus 3? Okay, so there's 17 total. Okay, so now we're going to look at the left side. Okay, so between these 2 sets of oxygens, they have to equal 17. Okay, so how many are right here? 2. What's 17 minus 2? 15. So that means we have to make this one equal to 15. What times 2 equals 15? Okay, go ahead and lightly pencil that in. Okay, technically, are we balanced right now? Okay, we are balanced. However, can you have 7.5 oxygen atoms? No. So what you do, we're going to double all of the coefficients to make them whole numbers. If we're right here, if no coefficient is written, what number is implied? A 1. Okay, so I'm just going to put a 1 here for the moment. Okay, so they have to become whole numbers, and we have to keep this ratio, so I'm going to multiply each of those coefficients by 2. I don't think my iPad's going to let me erase, so I'm just going to write in red below. So what's 2 times 1? Okay, so this coefficient really becomes 2. What's 7.5 times 2? 15. What's 7 times 2? 14. And what's 3 times 2? 6. Okay, so if you can erase like your old coefficients and write these in. My iPad just doesn't let me erase after so much time. Okay, so now we're just gonna check one more time, make sure we didn't have a mistake while we were doubling our numbers. So what's 2 times 7? Okay, so there's 14 carbons, and how many carbons are over here? 14. Next, 2 times 6 is, so 12 hydrogens, and what's 6 times 2? 12 hydrogens. Okay. We have 2 times 2, which is 4. And what's 15 times 2? 30. So 34 total oxygens. Okay. What's 14 times 2? 28. And this 6 carries over, so it's 28 plus 6. 34. Are we balanced?